All right, scholars, we are getting set to wrap up our journey through curve sketching with about 3 more lessons to go. To this lesson and the following lesson will be a 2-part series on polynomial division, utilizing 2 different techniques that ultimately allow you to arrive at the same conclusion. So we're learning to use long division once again to find the quotient of 2 polynomials, so I can compare and contrast diagrams and long division as ways of representing division. I'll know I've got it when I can use long division to divide polynomials. So let's begin. On our left-hand side, we have this diagram here, which takes the area model and demonstrates the process for taking an expression in factored form and rewriting it into standard form. Our area model for part C is empty, but if you look at the previous 2 examples, you should be able to tease out the method behind the madness. So I'd like for you to start some dialogue with your classmates, writing down 2 things that you notice and 2 things that you wonder from the diagram, and share that with the class before proceeding to our next slide. So Priya wants to sketch a graph of the polynomial f defined by this function. If you look at the function, you'll come to notice that even though there are 4 terms, it is not a function that is factorable by grouping, nor are there any other techniques that we can utilize in order to determine what the factors are for this particular polynomial. We do know that a characteristic of the polynomial is f of 1 is equivalent to 0. So we suspect that the expression x minus 1 could be a factor of this polynomial. We would like to take the standard form of the polynomial here, x cubed plus 5x squared plus 2x minus 8, and rewrite it as the product of its factors. I will demonstrate how we can reverse engineer the area model to assist us with this process. So if we look here, we can see that we have our first term, x to the 3rd power, and we should be asking ourselves, what term can we multiply by x in order to get x to the 3rd power? Remember, if I want to type math, I'm going to press that little tilde button next to the 1. That term in particular is x to the 2nd power. X to the 2nd power times x will provide us an x to the 3rd. And here I would just finish out this particular column by completing the multiplication with the bottom row of -1. We are currently trying to figure out what comes next in our table, and this is where we need to rely on the next term in the polynomial, so 5x squared. We currently, within our area model, have a negative x squared that when I add 6 to, 6x squared minus x squared will give me a positive 5x squared, which also allows me to determine that the next term of my factor is 6x. I'm able to fill out column 2. Nice thing about division is that it's a very repetitive process. So we look at the next term in a polynomial, positive 2x. How can I modify the negative 6x I currently have to create a negative or a positive 2x? I can add a positive 8x to it. If you want to put a plus here, you're more than welcome to. But remember, if we don't have a symbol there, we assume it to be positive. And we multiply x by 8 in order to create an 8x. And you should come to realize that you've effectively factored this polynomial with the constant term being the final term in our area model. This goes hand in hand with the definition of a factor. When a term or numerical value is considered a factor of another number or another polynomial expression, there should be no remainder. So I can just change these question marks And then it will be your responsibility to take this factored expression and rewrite it as the product of three linear factors. Right? We have one factor here of x minus 1, so we must factor our quadratic polynomial into two separate factors altogether. So that way, we've successfully taken our standard form of the polynomial and rewritten it as factored form, which will help us on our next slide when we need to create a sketch. Right, so we're starting to kind of throw all these ingredients into our polynomial sketching stew. Okay, over the next couple slides, we're really going to start to master this skill. So you are provided with some polynomials and they're a factor, and it is your job to factor those expressions accordingly. This table here is blank because I think you need to become familiar with also creating your own area models. So you can use the previous 3 slides to help you express regularity in your repeated reasoning. And then I give you a massive table that you can add rows to if need be. Don't just necessarily assume you have something typed here. So we put a dot, then we can add a row. Don't just assume that all tables will be built the same. You need to obviously be able to interpret the information that you've been provided. And for this particular slide, your factor is not linear because it is x to the second power. So I will leave that to you. And that's where we will pause and pick up together in class.